Welcome back. In Part 1, we explored regional climate patterns across the globe. Now in Part 2, we'll focus on how pilots use area climatology in real operations, including seasonal charts, met data, and effective pre-flight briefings. Let's start with seasonal climatology charts. These show long-term trends in temperature, wind direction, visibility, precipitation frequency. They are often used during route planning, especially for international or seasonal flights. Imagine flying from Madrid to Cairo in July. Seasonal charts show high temperatures and low rainfall. That means hot, dry, stable air, but also density altitude issues and turbulent afternoons due to surface heating. Climatology charts also show wind roses, which display prevailing wind directions and speeds by month. These help you predict likely runways, tailwind risks, or crosswind trends, key for payload and performance calculations. Let's say you're flying into Amsterdam in November. The wind rose shows dominant southwesterlies. So expect runway 1836 usage, frequent gusts, and low cloud layers tied to Atlantic depressions. Next up, precipitation patterns. Seasonal data shows how often rain or snow occurs at a given airport. This helps in choosing alternates and preparing for runway contamination, braking issues, or approach visibility changes. In Canada, charts show high snow probability at airports like Montreal in December and January. So when planning alternates, avoid other snowy destinations and pick fields in different weather zones when possible. Now let's look at META and TAF climatology. Some flight planning systems can show average METARs by hour or day, based on historical data. These show the typical visibility, ceiling, and wind at a given time of year. Example: arriving in Delhi at 6 a.m. in January. Historical METARs show frequent dense fog between 3 a.m. and 9 a.m. This helps plan fuel for holding, alternate selection, and brief crew on possible delays. Let's talk about icing probability charts. These show the likelihood of icing conditions by region, altitude, and time of year. They're especially helpful when flying through mountainous or temperate areas with cloud layers. In Europe, these charts show peak icing between November and March at FL 050 or FL 180. Knowing this, pilots brief for anti-ice use and add fuel for increased burn during climb or descent through icing layers. Climatology data also informs turbulence planning. By studying historical reports, dispatchers know where and when cat or mechanical turbulence is most common, like over Japan in winter or the Rockies year-round. Example: a flight from Denver to Seattle. In March, charts show frequent mountain wave activity. Crews might plan to fly higher or take smoother airways. Passengers are briefed to stay seated during climb-out. Now let's touch on alternate selection using climatology. Say your destination is prone to fog every morning in October. Your alternate should ideally be in a different climate zone, like a coastal vs inland contrast. Flying to Milan in November? Consider an alternate like Nice or Rome, locations with different weather influences. That way, one system isn't likely to affect both airports. Here's another tip: departure windows. Using climatology, airlines can schedule flights when visibility, wind, and traffic are most favorable. For instance, Caribbean flights often leave early to avoid afternoon storms. Now let's look at data sources pilots and planners use. ICAO climatology tables. NOAA and WMO seasonal summaries. Airport climate briefs. Airline route analysis tools. Satellite data archives. All these help build a broader view than just daily METARs. Let's say you're dispatching a freighter across the South Atlantic. Charts show CB frequency peaks at night in the ITCZ. The crew schedules a daytime crossing, avoiding most convection and flying a slightly longer but safer route. Let's not forget climate-linked NOTAMs. In seasonal snow or sandstorm regions, runways may be closed routinely. Charts help spot patterns, and flight crews can preemptively adjust fuel and routing to accommodate. For example, in Mongolia or northern China, blowing snow and low visibility are common in January. Climatology shows closures spike on certain days. Planning ahead can avoid costly delays. Briefing climate to crews is also key. Captains should be told what conditions are probable, which weather is most hazardous, when and where it usually develops that way. They aren't just reacting to a sudden meta, but expecting and planning for it. Let's recap. Area climatology helps forecast risks beyond the TAF. It improves alternate choice, fuel planning, and runway expectations. It enhances safety by preparing for patterns, not just surprises. It's a crucial part of professional dispatch and command decisions. In the next episode, we'll wrap up area climatology with Part 3, focusing on specific flight case studies and how to apply all this data in real decision-making. See you in Meteorology number 47, Area Climatology, Part 3.